Okay, this video, we're going to go through the derivations of formulas for the vertex from standard form and the quadratic formula. If you have not yet fully grasped the concept of converting a quadratic from standard to vertex form using the completing the square method, you're going to want to go back and watch that video first because we're going to use that strategy as we kind of move through here. So let's start with the quadratic in standard form. So we've got the general formula, y equals ax squared plus bx plus c. This should look familiar to you. This is a quadratic in standard form. Okay. Our goal is to put this in vertex form so that we can then go ahead and identify the vertex. And then that's going to give us our values for the x coordinate is going to be h, and our y coordinate is going to be k. Again, thinking about this in the format of if I have this in vertex form, it looks like this, right? So where h comma k is our vertex. So our goal is to put this in this format so that we can then very easily identify h and k. All right, so let's do that. First of all, we're going to go ahead and complete the square here. So we would move that c over, that constant, to get it out of our way temporarily so that we don't have to really worry about it, right? So move it over to the left-hand side by subtracting it from both sides. Okay. Next, when we're completing the square, we need to factor out that a, right? So that lead coefficient, we want to get that not in our problem. So if I divide all the terms by a, it's going to look like this. Okay, and then when we start thinking about this, y minus c, I'm going to leave a little space there, is equal to a times, this is going to be x squared plus b over ax plus something, right? And we have to figure out what the heck we're going to actually add there. And what we're going to add there is going to end up being half of b over a squared, right? So that when I get this in its factored form, it's going to be x plus half of b over a squared. So we like to simplify this and clean it up, right? So instead of writing 1/2 times b over a, we're just going to write this as b over 2a. So I'm going to rewrite this expression right here as b over 2a. So this is b over 2a. And then I know that to complete the square there, so that the red statement is actually equal to the green statement here, I actually would end up squaring b over 2a to get this. So this is going to be b squared over 4a squared. Now, technically, what I did was I added this quantity on the right-hand side. The quantity a times b squared over 4a squared got added to the right-hand side. That simplifies to b squared over, divide those a's out, over 4a. So I added the quantity b squared over 4a on the right-hand side. I need to make sure that I also add that quantity on the left-hand side. So right now I have y minus c plus b squared over 4a is equal to the quantity, a times the quantity x plus b over 2a squared. Okay, and then last step, I need to go ahead and move my constant back over so that this is in vertex form. And I do that by adding c and subtracting b squared over 4a. So if I do that on the left, I need to go ahead and do that on the right. So I'm going to add c minus b squared over 4a. And so now we have this in vertex form, where our vertex is going to be the opposite of this number, right? And then exactly what we see for this number. So the vertex is negative b over 2a, comma, c minus b squared over 4a. And so if we were to write the formula for the x value of the vertex, it would be opposite of b over 2a. And for the y value of the vertex, it would be c minus b squared over 4a. Now, oftentimes we don't actually calculate y using that particular formula. Could we? Absolutely. But most times what we do is we first find the x coordinate, and once we know the x coordinate, we can just substitute that back into the standard form to find the y coordinate of the vertex. So that's what we do most often. But that is exactly where those values come from. And now I want to actually go to this form right here and say, what if I asked you to find the solution? So I'm going to rewrite that down here, what we just derived, right? So in converting a standard form into vertex form, we have the following. And what we want to do is we want to go ahead and solve this for x. So my goal is to solve this. So if I'm finding the solutions, that means that I'm looking for x-intercepts. I'm looking for where the y-coordinate is 0. And I'm just going to go ahead and start thinking about how I isolate that x value. So right now we're starting to derive the quadratic formula by solving this, this quadratic in vertex form. So to get there, I'm going to subtract this quantity, c minus b squared over 4a, from both sides. So I have negative c plus b squared over 4a equals a times x plus b over 2a squared. I don't like the left-hand side being two separate fractions, so I'm going to go ahead and make those with one common denominator right now. So I'm going to make a common denominator by multiplying. If I try to add negative c and b squared over 4a together, that looks bad. I need to make a common denominator. I'm going to multiply negative c by 4a over 4a. So this becomes negative 4ac plus b squared all over 4a. Not really a fan of the way that looks. I'm going to actually put the b squared first, just because I like to have those higher exponents in the beginning. So I'm going to rewrite this as b squared minus 4ac all over 4a. So all I did right now is make a common denominator on the left-hand side and rewrite the left-hand side. Okay, we're still trying to solve for x here. So the next step to solve for x would be to divide by a. And dividing by a is the same as multiplying by 1 over a, right? So dividing by a number is the same as multiplying by its reciprocal. I'm doing that because on the left-hand side I've got a fraction divided by another fraction. That'll look a little nasty. So this ends up being b squared minus 4ac over 4a squared equals the quantity x plus b over 2a squared. All right, now I need to get rid of, I'm still trying to get x alone here. So now I'm going to go ahead and take the square root of both sides. And remember, anytime I take the square root of a quantity squared, it's going to be plus or minus. So on the left-hand side, I have plus or minus the square root of b squared minus 4ac all over 4a squared, which equals x plus b over 2a. I can clean this up a little bit because I noticed that in the denominator, both of my denominator terms are perfect squares. So I can actually simplify that using the square root or the radical. So what I'm going to do is I'm going to split this into two separate radicals. So it becomes like this. And I'm doing this the long way. You might have seen this and been able to manipulate this on your own, but I'm just kind of going through and making sure I'm not skipping any steps. Right? So I'm splitting up that radical in the numerator and denominator, and the reason I'm doing that is because both 4 and a squared are perfect squares, so I can actually simplify the denominator to just be 2a. And I like that because on the right-hand side, to isolate x, I'm going to have to subtract b over 2a. And so I'm going to do that on the left-hand side. And so what I end up with is negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And that should equal x. And we know the quadratic formula to be x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which we can just combine those fractions because they have the same denominator. Voila! And there you go. There is your derivation of the quadratic formula from a quadratic in vertex form. That's it. I hope that helps. Happy studying.